Solving problems with torque. Always draw an extended free body diagram, or force diagram, as part of the solution to any problem that involves torques. Free body diagrams are separate from extended free body diagrams in that a free body diagram removes the body and all of the forces are coming from a single point. Meanwhile, an extended free body diagram shows where the forces are actually happening. For example, if friction is causing a wheel to rotate, then you would draw the frictional force vector at the point of contact between the wheel and the surface that it's on. A couple things to remember: weight always comes from the center of mass and points downwards. A normal force is always perpendicular to the surface and comes from the surface. Remember, draw lengths proportional to magnitude. So a longer arrow means a bigger force, a shorter arrow is a smaller force, and make sure you are labeling all of your forces. In problems of this kind, apply Newton's second law for translation to any object that's changing position, and Newton's second law for rotation to any rigid body that rotates. Both laws must be applied to any rigid body that undergoes both translation and rotation. If there are problems that have translation and rotation, you would need to relate your acceleration, for instance, to translation. So your angular acceleration equals a over v. Your angular velocity equals v over r. Remember those relationships. Here's an example of an extended free body diagram where we have the frictional force coming from the point of surface, the normal force coming from the surface, the weight force coming down. The only thing that's wrong with this diagram is there are the components of the weight force drawn on the diagram. You know that we don't do that.